All right, my name is Mr. Geppert, and I'm here at Cape Fear Community College Computer Integrated Machining Program to show my students how to best use dynamic roughing in Mastercam. And we learned something new here a little while ago, courtesy of the Barefoot people, and we're here tonight to talk about it. In the past, we were making, anyway, this step block from NIMS. And in the past, we had to attack the part using different Z levels and different tools, actually. But we found on a different part that had pockets that you can use dynamic OptiRough, which had in the past only been used for 3D parts, that you can use this for 2D parts and not have to worry about the Z levels anymore. The way this comes about is mainly through the fact that if you set the step down to equal the step up, and you set an outer border, and then tell it to take a strategy from the outside, Mastercam pretty much figures out the rest of it on its own. The roughing of the outside, the roughing of this step, and this slot was all done in one toolpath. So, if you would please come up, Austin, and show them the toolpaths that you use to make this whole part. All we're going to talk about here is dynamic facing and OptiRough from the inside with the construction border. The construction border is this blue line that we drew around the top of the part that is only slightly larger than the stock box. All right? So, I went to up here on the 2D toolpaths and just chose the standard facing toolpath. We cut this part out of by the way, this is tool steel, A2 tool steel, and we left about 1/4 inch of stock on the top, quite a bit on the bottom to hold it. As you can see here, that's what we had in the vise to hold it. And we left 1/4 inch of stock on top to hold it, and we used dynamic facing to face off the stock. Here are the parameters for dynamic facing. We just used a 1/2 inch flat end mill. We set a feed rate, and we turned it up on the machine, really, of about 75 inches per minute and 6,000 RPM, which is about 785 surface feet per minute. The cut parameters were here. We set the style to dynamic, and it turned out that we set an approach distance of 1 inch away, and we set our step over. We could have been a little bit more generous, maybe 10 or 12% would have been fine for this dynamic roughing. We left 15,000 stock on the floors because we wanted to come back with a 3-inch face mill to leave a nice smooth finish on the face. Okay, now the linking parameters were all the same since we left the stock there. But here's another thing that they showed us at Barefoot CNC is this arc filter tolerancing can be set so that you cut down greatly on the amount of code that goes out on the machine. This was a problem for us. Our machines don't hold a lot of code, and we were having to cut up toolpaths or just send one toolpath at a time. We set the total tolerance here to 5 thousandths, and that cut down a lot on the code, but especially setting the line and arc filter settings, we just checked these 3 boxes, which allowed us to go back up, and then you set the line arc tolerancing to 50%. So what this does is the lines and arcs are not drawn so nicely and tightly, and it cuts down like 90 or 80% on the amount of code. Well, why not? We are just roughing. We're just cutting a rough part. We don't care about the finish necessarily all that much either. We want our tool to last, and we want to get rid of material. But mostly we want to get rid of material. We don't care really all that much either about the false economy of a tool lasting. If the tool lasts a decent amount of time and we get rid of we get our part off of the machine in 70% less time. Well, that's wonderful. So that's dynamic facing. That's been available to us for quite a while. So let's quickly backplot this and look at the amount of time, 1 minute and 38 seconds to do that, and the toolpath used 31K of code. If I go back and I change this to 1/1000th tolerance, and I take the line filter off, and I change this to 5%, say, let's say, the cut tolerance, to 1, apply it and go back, and I regenerate real quick, it goes to 389K of code. That is way more. 31 versus 389, that's 90%, that was 90% more, or however that would be figured. So we can leave that, let's just go back and do the, this again, 0.005, then you set the line arc filter settings, 1, 2, 3, then we change this guy to 50%, and we are good to go. Regen, back down to 31, and let's watch the motion from above. Speed her up a little bit. Our cutter has a little 15,000 radius on the side, and in the very center sometimes it'll leave a little radius island. So this does not necessarily face off all that well, and you may want to. Minute 38 seconds for the facing. So then we skim cut the face, so now we can go ahead and show you the wonderful OptiRough, usually a 3D toolpath from that is going to rough the entire part out with one toolpath. You see here, and this is Mastercam 2018, by the way, not even 2019. We leave 10,000 stock on the wall, 23 entities. It's basically just a solid model that drives all this. The containment boundary is this blue box. That is the containment boundary. The strategy is from outside, compensate to the outside. Didn't touch anything else. No offset distance, no starter point. 1/2-inch flat end mill, I called it a ripper. It was an Ingersoll Rand 5 flute, coated end mill, 1.5 inches of flute length, and we're gonna go down 1 3/8. So 6,000 RPM, 785 SFM, 75 feed rate. Plunge rate is 25. You got to watch this in Mastercam. Sometimes you'll go out with your code and this will be 0.1, and you're doing all this other great milling, and your cutter just slowly goes down to get ready and set up. So you got to watch that plunge rate. Anyway, then you go to cut parameters here. This is where the action is. We have an 8% step over as usual. However, you make the step down equal the step up. In this case, the part is 1 3/8 deep. So I set that to 1.390 to make sure that the cutter would go all the way down to the bottom. You're going to do that too as you follow up here with your parts. And so then we set the minimum toolpath radius, which is another thing we learned at. If you would zoom in here so that you can see. This minimum toolpath radius is critical. The standard, or the way it normally comes out on default, is a big toolpath radius. And in the past, it prevented my 1/2-inch end mill from letting me go in here to do that lovely tool motion in the center slot. So when we set this to only 15%, we're only increasing the toolpath radius or the area that it will fit in by 150 thousandths. By knocking this number down with the barefoot CNC guys, we then got it to do the entire part. So step down equals step up. And then it stepped up all the way and found all these other features on the part, all on its own, Mastercam did. We turned off steep and shallow. You can use this to detect the depth of the part, but we didn't have to do that because we knew it from our blueprint here. And now we set the arc filter tolerances to half of the stock on the wall. There's that 50%. And here are the planes. And all the rest of it we did nothing with. Linking parameters just sets up the air cutting moves. We don't have to do anything there. In the past we had to check this output feed move, but not anymore. Guess what? We're ready to cut apart in one toolpath. Rough it completely, leave 10,000s on everything, and not have to touch the geometry, not have to worry about Z. Let's verify it and have a look at it like this. I was really excited to see this because also the total time to rough this whole part out of an A2 tool steel with lots of stock to get rid of, 6 minutes, 6 or 7 minutes. And here I'm going to slow it down at first, turn up the precision, get rid of the gnomon and the axes, and I'll leave the wireframe and the stock and get rid of the holder. And here we go. It goes around, that's too slow. Around the outside, that first pass misses the corners. So this worked out very well on the actual part. Here it is finishing it had more stock on the front and the back. Here it finishes the front. And like I said, no worries about Z. Here she steps up. This is the identical motion that it used to give us in dynamic contour. But I don't have to do that. Mastercam gives me dynamic contour automatically. Love that smooth motion. The tool doesn't squeal when we're out on the machine making it on our old Haas VF2. And here is that motion coming back from the backside, cutting this 3/8 deep slot right dead through the back. I'm going to move it from the top so you can kind of see it that wallowing motion that I really like. That would take forever to program something like that by hand. Yeah, then now we come back for the last step, and it stays on those ears. It doesn't cut any air. Yep, lovely. And though it comes back up to cut these faces like this, that stock has already been taken care of by a previous facing operation. Voila, part roughed out. One operation, no geometry clicking. All we did was click on this box and tell it the model, click on the whole model. Yeah, we clicked on the whole model and told it to leave 10,000s on every face. And it did that in reality. Here is the NIMS step block and the results. So, thank you very much for listening. We're going to post this to our Facebook page and Mr. Geppert's Computer Integrated Machining YouTube. Thank you.